We're starting part B of section 3.2 on range, variance, and standard deviation. And we went through a lot of language and a lot of description of what it is. And we talked a little bit about its reference to reaching the bell curve. But the use of these tools of measurement is to validate either the connection to the population or to analyze the high span of the data, which then calls the question to uh, what is happening within the collection of the data. So here we go. We're doing now examples. And here we go. Sorry, got hung up for some reason. I have no idea. Okay. So our first example reads, the 161 heights of males. So that means that in this case are in the 161 heights of males uh, from a data set of body measurements vary from a low of 158 and no decimal centimeters to a high of 194 and 9/10 centimeters. Use the range rule uh, of thumb to estimate the standard deviation S. So we're looking for S of a sample. All right. So we're saying, and compare the results to the standard deviation of this guy. All right. So the rule of thumb is that we take the, let me see if I can get right here, sorry, the max X minus the min X, which is the range, and we're going to divide by 4 for those partitions of 2 standard deviations around the mean. Okay, so that's what we're going to be doing. And the numbers are, of course, the 194, sorry about that, and 9/10 centimeters subtracted from the low, 158, and no change divided by the 4 to figure out how many partitions we have of this data. Here we go. So we're going to take the math. Let me get my calculator. Right, I think you can see it. I'm going to clear the screen from what we did before. Open parentheses, 194.9 minus the 158, close parenthesis, divided by 4, and enter. 9 point, I'm going to put it on this side, 9.225. Okay, now remember they had 1 decimal. So, so we're going to do 2 decimals. So that means that it's approximately 9.23 centimeters is the rule of thumb standard deviation. Alrighty, so we did that, and now it says they want us to compare. All right, the standard deviation of 10 and 6 hundredths to the actual data of the estimated calculated. So we want to compare, so that means to take a difference. So we're going to take our 10 and 6 hundredths and subtract from it our 9 and 23 hundredths to find the variation within those standard deviations. So I'm going to get out my calculator again. I'm going to enter the 10.06 minus the 9.23. Very small amount. All right. Small. It's very small. All right. So we've got that. And now we're going to fill in the line. It says on this one, assume the estimate is accurate if it's within 1 7/10 centimeters. In other words, they're saying we find it to be sound to represent the sample, even though you didn't do the math on all of the data. You used a quick and dirty to do the standard deviation. So that was a test of the range. All right. So the approximation, and it should be is, I put the answer in there, didn't I? Is, and I've lost my pen. Okay, I'm going to stop right there, and I'll start right there, and once I can unlock the computer. Thank you for listening.